Welcome, focused learners, to this explainer. I am your host, your strategist, and today we are embarking on a really exciting journey that I like to call the archaeological dig. We are taking a massive, deep dive into Cambridge computer science exam strategy. Our mission today is to uncover the hidden clues that are buried deep within complex past paper questions and, layer by layer, reveal the absolute perfect answer for the Cambridge computer science exam on radio waves and wireless communication. To set the stage for you today, I want you to picture a real past paper question in your mind, specifically looking at the incredibly rigorous standards of Code 9713 and 9618. I want to introduce you to two archetypal students. You might even recognize a bit of yourself in them. On one side of our mental split screen, we have Alex. Now, Alex works hard, but Alex overloads answers with raw computer science facts about frequency bands and attenuation, but provides absolutely zero analysis. It is literally just a data dump of textbook memorization. On the other side of the screen, we have Sam. Sam always rushes through the exam completely missing the command word requirements. Sam describes when asked to evaluate and states when asked to explain. If we were to look at their exam scripts right now, they would just be covered in red pen marks. It's heartbreaking because they are losing crucial points despite actually knowing the subject matter. Well, today, we are going to transform those red marks into green check marks. We are going to build a system so foolproof you'll never leave those easy marks on the table again.
Take a look at this quote right here. I'm going to show you exactly what examiners look for. This is from a senior subject specialist, and it is our entire hook for today. We aren't just sitting here discussing dry textbook theory. We are actively dissecting the actual assessment framework. I am promising you direct, actionable insights straight from the people who actually grade your papers. We're going to unearth those hidden expectations that trap hardworking students like Alex and Sam year after year.
All right, let's look at our roadmap for today. We're going to hit the core principles of wireless, then the method mark strategy, move into the top 3 examiner warnings, and finally, evaluation and exam strategy. It's a packed explainer, so let's get right into it.
Section 1. Core Principles of Wireless. Theoretical Foundations.
Okay, notice the battle happening here on screen. Analytical depth versus superficial breadth. This is absolutely crucial to understand. The assessment framework strongly, and I mean strongly, prioritizes deep analytical understanding over just knowing a little bit about a lot of things. Think back to Alex, our student who just dumps raw facts onto the page. If asked about setting up a network, Alex might write, Wi-Fi uses 2.4 GHz and 5 GHz bands. Period. That is superficial breadth. It's a true fact, sure, but it earns minimal marks. To achieve the analytical depth that examiners are literally begging for, you must apply the Peel framework. That stands for point, evidence, explanation, link. Let's break that down. Your point might be, 5 GHz provides higher data transmission rates, but a considerably shorter range. Okay, good start. Then, your evidence. You extract data from the specific exam scenario you were given. Let's say the prompt mentions it's an old office building with incredibly thick concrete walls. Next, your explanation. Higher frequency waves experience significantly greater attenuation when passing through solid objects compared to lower frequencies. And finally, your link. Therefore, in this specific office scenario, a 2.4 GHz network or a multi-node mesh system is absolutely required to ensure reliable, building-wide coverage. Do you see the massive difference there? The examiner isn't just testing your memory. They are testing your logical, structured reasoning. They want to see you think like a computer scientist, not a flashcard app. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
And this brings us to a massively important data point pulled straight from the principal examiner reports. Top students transfer conceptual understanding to unfamiliar contexts. They do not just talk about radio waves in a vacuum, they connect it to other syllabus areas. This is where you separate the A-grade students from the rest of the pack. Examiners love it when you ask and answer questions like, how does packet switching actually function over a wireless network where interference is high? How does CSMA/CA, carrier sense multiple access with collision avoidance, handle data collisions on a crowded Wi-Fi channel? How do encryption protocols like WPA2 or WPA3 secure these airborne radio waves that anyone could technically intercept? Candidates referencing these brilliant cross-topic connections achieve significantly higher marks because they demonstrate a holistic, connected understanding of computer science. They see the whole matrix, not just a single line of code.
Let's move on to Section 2, the method mark strategy, technical methodology.
Here is our step-by-step processing sequence, and it is a game changer. Whether you're studying syllabus 0417, 0478, 0983, 0984, 2210, or the highly rigorous 9618, this applies to you. Step 1 is where our rushed student Sam always fails. Deconstruct the question. You must act like an archaeologist identifying a dig site. If the command word is describe, you just provide characteristics. But if it is explain, you must provide reasoning, the why or the how. If the command word is evaluate, you must analyze pros, analyze cons, and come to a justified conclusion. You have to deconstruct that command word first, or you're answering a question they didn't ask. Then, step 2, extract relevant data from the scenario. Step 3, select your analytical framework, like the Peel method we just mastered. Step 4, execute with clear notation. And step 5, present with perfectly correct terminology. Never ever write, the signal gets weaker. You must say, the signal experiences attenuation. Professional terminology signals to the examiner that you belong in the top tier.
This systematic decomposition also directly applies to algorithmic thinking and complex radio waves problems. So it's time for our first interactive workshop challenge. I want you to mentally visualize those red pen marks transforming into beautiful green check marks. Imagine a progress bar on your screen right now, rising rapidly from 0 to 100% mark potential. I'm giving you a 60-second mental timer for a rewrite attempt. Are you ready? Let's say Sam was asked to explain how a router uses a routing table in a wireless network. Sam, in a rush, wrote, "The router looks at the IP address and sends the data over Wi-Fi." Stop right there. That is a massive red pen answer. It's too vague. To turn that green, apply step-by-step decomposition. Mentally write this with me. First, mention the router receiving the data packet from the wireless interface. Second, mention it stripping the frame to read the destination IP address. Third, mention it comparing that specific IP against its internal routing table to find the most efficient next hop. And finally, mention it repackaging the data into a new frame for transmission over the selected medium. Boom! That is the computer science success blueprint in action. It's methodical, it's precise, and it earns every single available mark.
Data interpretation skills are absolutely critical here. Examiners want to see you extract from binary representations, perform precise calculations, and draw hard, evidence-based conclusions. Let's do a quick data scan challenge right now. Imagine a complex data chart in front of you, showing signal strength over distance for different wireless frequencies. You have a 60-second visual countdown timer ticking down in your mind. What is the core trend you must extract to get the marks? You shouldn't just read the numbers off the chart. Anyone can do that. You must conclude the inverse square law relationship. You need to state that as distance doubles, signal strength drops significantly, and crucially, it drops exponentially faster for higher frequencies like 5 GHz compared to 2.4 GHz. You must follow these specific actions to verify your results and prove to the examiner that you can interpret raw technical data, not just recite textbook definitions.
Moving right along to Section 3, Top 3 Examiner Warnings, What to Avoid. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, back to the dig. I want to pose this question directly to you to encourage some active recall. We are entering our Find the Flaw challenge. What do you think is the absolute #1 mistake candidates make when answering these wireless communication questions? Listen closely to this flawed sample paragraph. The company should upgrade to a 5 GHz Wi-Fi network because it is a much better radio wave. It will give all employees faster internet, so the network will be completely secure from hackers outside the building. Take a mental 30 seconds. Identify the sentence losing marks. Where did our student go completely off the rails?
Let's reveal the top 3 mistakes straight from the examiner commentary and see if you spotted the flaw. First up, confusing cause and effect. In our flawed paragraph, the student confused frequency speed with network security. Yes, 5 GHz provides faster data transfer rates, but it has absolutely nothing to do with being secure from hackers. That requires robust encryption protocols like WPA3, not just a frequency change. It's a classic mix-up of 2 completely different concepts. Second, forgetting boundary conditions and edge cases. Students constantly forget that radio waves do not travel infinitely. They ignore the physical limits, the edge cases, like the maximum range of a router before attenuation makes the signal useless, or the maximum number of concurrent device connections before the bandwidth is completely saturated. You have to mention the limits of the technology. Third, providing answers not specific to the context. This is exactly what SAM does. If the exam question is about deploying wireless sensors in a massive, muddy agricultural field, giving a generic textbook answer about office routers will score you a big, fat 0. You have to talk about weather interference, distance, and lack of power outlets. You easily avoid these traps once you integrate this awareness into your strategy.
Section 4. Evaluation and Exam Strategy, the final polish. This brilliantly illustrates how you must evaluate algorithm quality. Think about the time management matrix here. You absolutely shouldn't spend 10 minutes evaluating time complexity for a tiny 2-mark question. But for a high-value extended response, you must compare alternatives and make beautifully justified recommendations. If you're evaluating a protocol for handling wireless data transmission, you need to identify its effect on performance. For example, does the algorithm take way too long to establish a handshake? That's time complexity. Does the encryption overhead require too much memory on a tiny, low-powered IoT device? That's space complexity. You have to check these boundary conditions and thoroughly justify your reasoning to get those top-tier evaluation marks.
So the crucial point here is mastering this complete critical analysis loop. Finding an answer isn't enough. You must systematically verify and justify it. Let's do a 30-second speed writing challenge. I want you to imagine a big timer counting down on your screen right now. The prompt is, recommend a wireless frequency for a busy, multi-story warehouse. Go through the loop with me. Deconstruct. Need a recommendation with strong justification. Break into steps. Consider 2.4 GHz versus 5 GHz in an environment packed with physical obstacles like metal racks. Solve. 2.4 GHz penetrates walls and metal much better. Check reasonableness. Will the warehouse have interference from other machinery or microwaves in the break room? Yes, absolutely. So maybe specific non-overlapping channels are needed. Make justified recommendation. Formulate your final PEL paragraph. Recommending 2.4 GHz on non-overlapping channels specifically due to the physical boundary edge cases of the metal-filled warehouse. Time's up. If you thought through that, you just secured full marks.
This leads us to the ultimate golden rule for exam success. The classic mistake is providing generic answers. Examiners genuinely despise reading the exact same memorized bullet points from a textbook that have absolutely zero relevance to the specific question asked. Context is king. You must always link every single point you make to the given scenario. If the scenario is about setting up Wi-Fi in a hospital, you must mention medical equipment interference and life-critical reliability. If the scenario is about a local coffee shop, you must mention public network security, rogue access points, and captive portals. Generic answers will always lose marks. Tailor your knowledge to the story they give you.
As we conclude our massive archaeological dig today, I want to leave you with this final, provocative thought. How will you connect your methodology directly back to the context in your very next practice paper? Are you going to be an Alex, just dumping raw facts and hoping something sticks? Are you going to be a Sam, rushing blindly and missing the command words? Or are you going to use the 3 rules that guarantee top marks: command word decoding, the PEL framework application, and the time management matrix? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.